Moving heavy objects was once the hardest part of any really big job, but somehow people have managed to find ways to move big loads when they've had to. Over the years, we've developed rigging techniques that make it easier to lift and move heavy objects. Rigging includes the use of ropes and chains, connectors and other special attachments. And it also includes the use of hoists and cranes to lift and move a load. Whenever you're doing a rigging job, safety is the #1 concern. Wearing protective equipment is important. But alertness and good practices are just as important no matter what size the load. The need for safety in rigging is pretty obvious. When you're lifting loads of several tons, you've really got to be careful about where they come down. Now, when we talk about rigging safety, we're really talking about 3 different things: planning the job, inspecting the equipment, and using the equipment properly. We'll be talking about each of these important points, but we'll do it one at a time. Let's start with the first part, planning the job. Planning a rigging job consists of 4 steps: finding the weight of the load, finding out how it's balanced, checking clearances to make sure you've got room to move the load, and selecting the equipment you're going to use. Now let's go through these steps one by one and see how to find the information you need. The first thing you need to know is the weight of the load, how big a job is, and how heavy will your rigging equipment have to be. Sometimes you can find the weight of a large piece of equipment stamped on the manufacturer's ID plate. Other times you'll have to go to an equipment manual or an operator's guide to find the weight, or you can check the shipping papers. But sometimes the information you need is missing or simply not available. When you can't find the weight for sure, you have to estimate it. The one way to estimate the weight of a load is to compare it to the known weight of a similar piece of equipment, maybe one of a different size. Another way to estimate weights is to calculate the volume of a load and refer to a table that lists the weights of different materials by volume. Finding the weight of the load is the first piece of information you need whenever you plan a rigging job. If your load weighs a ton, every piece of rigging equipment has to be rated for at least a ton. And generally, it doesn't hurt to over-rig a little bit. For example, you might use a 1.5 ton hoist to lift a 1 ton load, just for that extra safety margin. Okay, after you find the weight, you have to find the balance of the load. And the balance is important because if a load's picked up off balance, it'll tilt and start to swing. And the last thing anyone needs is a couple of tons swinging through the air on its own. When you find the balance of a load, you're looking for a single point where you could pick up the load and it would stay perfectly level. That point is called the load's center of gravity. Now, a load is balanced when its center of gravity is directly beneath the load hook. For an example, let's take a look at a compressor. As you can see, the compressor is not a regular shape, so it'll tend to be unbalanced. Before you could lift it, you'd have to find its center of gravity. But how? One way would be to make a model of the load. If we can find the balance point of this cutout, we'll have a good idea just where the center of gravity will fall. Now here's our hoist. On the line, we've got a load hook to lift the cutout and a plumb bob to give us an accurate up and down measurement. What we're going to do is lift the load from each of these holes and mark a line straight down from the pickup point. Okay, there's our first line. And our second line. And our third line. Well, here's the third line. Notice that it crosses the other two at the same point. As a matter of fact, you can prove that no matter what point we lift the load from, the lines all cross right here. That means that this intersection represents the center of gravity of the load. Okay, if this point's the center of gravity, we should be able to lift it from this hole directly above, and the load will stay level. Now let's try it out. Well, there you have it. Now we know that if we go back to the original load, the real one, the load hook will have to be directly over this point for the load to be balanced. For a complex shape, you might have to take an end-on view of the load and balance that too. But the basic process holds true, even if you're attaching to the load at several different places. Here's an example. This load's being picked up at 4 points, but if the load hook isn't in line with the center of gravity, you may have a lot more to handle than you originally thought. So far, we've seen how weight and balance are important when you're planning a rigging job. All the information we're collecting is helping us select the technique and equipment we're going to need for the job. There's really only one more thing we have to know. We have to know where we're going with the load and how much room we're going to have. First, check the size of the load. Measure the width to find its smallest dimension. Then measure the length. Measure the width of any tight places along the way, even if they look big enough, to make sure you'll have enough room on the sides to avoid lifting the load above any other equipment. Once you've measured all the tight spots, you'll know for sure whether the job can be handled the way you've planned it. Weight, balance, and clearances. These are the 3 important pieces of information you need to know. Once you've figured in these 3 factors, you're ready to select your equipment. First, the weight of the load tells you how much each piece of equipment will have to support. Shackles and eye bolts should each be at least equal to the load they have to carry. And it doesn't hurt to give yourself an extra safety margin by choosing equipment that's rated a little higher than necessary. In general, your equipment should be rated higher and higher as you go from the bottom up. For example, this load weighs a ton. Its eye bolt is rated for 1.25 tons, and so is the shackle. The wire rope sling and the hoist are both rated at 1.5 tons. The balance of the load is the second piece of information that helps you select your equipment. Some loads are fairly easy. If they're balanced, all you have to do is lift from the middle. Other loads can be more complicated. This load, for example, is unbalanced. Its center of gravity is here. To lift it safely, the load hook has to be directly overhead, but the eyes are in these 4 corners. We'll need a 4-legged sling with 2 short legs to move the load hook directly over the center of gravity. When the load's picked up this way, it won't tilt or shift. It's balanced. We've seen how weight and balance affect the planning of a rigging job. Another important factor is clearances. Careful measuring is the only way to be sure that the load will fit through tight places along your planned route. You have to measure the load and its path to determine the clearances you'll have to work with. Last of all, you have to select the equipment, bearing in mind that any piece could be the weak link that might cause a serious accident. If any one piece can't support its part of the load, the whole thing comes down. So far, we've talked about 4 steps to follow when planning any rigging job. Find the weight of the load, find its balance, check clearances, and select equipment. No matter how large or small the job, these are the basic steps. You should be able to get any additional details you need, such as load ratings or special rigging techniques, by consulting a rigger's handbook or your plant safety manual. As I said before, safety is the #1 concern on any rigging job. And planning the job is really only one part of rigging safety. After you plan the job, you have to inspect the equipment and use it properly. A little later on, we'll talk about inspection and use of equipment in detail. But before we go on to the next part, take some time to go over your section 1 of your text. Answer the text questions, then ask your instructor about any questions that you might have. Of all the tools we use in rigging, ropes and chains are the most basic. Wire rope is perhaps the most common rigging tool of all. Some hoists use wire rope to lift a load, and often wire ropes are fashioned into slings to attach a load to a hoist. Chains are often used on smaller hoists, and they can be made into slings as well. Whenever you do any rigging, you'll be working with these two materials, rope and chain. Often you'll see them as they're used here, fashioned into slings. Slings are short lengths of rope, chain, or braided nylon that are used to attach a load to a hoist. Most wire rope slings are made with an eye at each end. Others are endless. They form a complete loop. Since ropes and chains and slings in general are so common in rigging work, it's a good idea to learn something about them. What we're going to do is take a close look at how ropes and chains are made, how they're used, and what makes a rope or chain safe or unsafe. We'll start with rope. The first thing you'll notice is that rope has several strands that are wound around each other. If we look closer, you can see that each strand is made of several wires. An end view of the rope shows a central core that cushions the strands. The core might be made of fiber, wire strands, or even plastic. If we look down the length of a rope, we can see that the strands are laid so that they spiral away from us in a clockwise direction, just like right-handed screw threads. This kind of rope is called right lay. Rope that spirals away in a counterclockwise direction is called left lay rope. Left lay rope is used only in special applications. Although we've been talking specifically about wire rope, most fiber ropes are made in a similar way. Threads, usually manila or nylon, are built up into strands, and the strands are laid up to spiral around each other, usually to the right. The main difference between the construction of fiber rope and wire rope, aside from the materials, is that fiber rope usually doesn't have a separate core. The strands wind around each other. They don't need cushioning the way the strands of a wire rope do. In the old days of rigging, natural fiber ropes like manila or sisal were used for just about everything. Today, most of their functions have been taken over by wire rope or synthetics like nylon or polyester. Wire rope is used for slings, for cranes and other hoists, and on winches. On modern rigging jobs, fiber ropes are used mostly for tag lines, lines that help control the swing of a load while it's in the air. Wire rope is used just about everywhere because it's stronger than fiber rope and lighter than chain. But there are certain disadvantages. First off, wire rope kinks. Once a rope is kinked badly, it can never be completely straightened out. Second, wire rope can unravel. When a rope is really unraveled like this one, it's called bird caging. Shiny flat spots on the rope signify wear or crushing. Badly worn ropes should be destroyed so nobody uses them. The same goes for ropes that are badly stretched. Compare the actual diameter of the rope to the figure listed in a rigging handbook for a new rope, and check the diameter in several places. If your rope is significantly smaller, it's been overloaded and shouldn't be used. Another thing to look out for is broken wires. They are dangerous for two reasons. First, if more than a few wires are broken, the rope is severely weakened. And second, the sharp ends of the wires make burrs that can cut your hands. That's why you should wear heavy gloves whenever you work with wire rope, unless you want your hands to look like you've been in a cat fight. Rusty or corroded rope is another kind of problem. This rope is no longer safe. It wasn't properly lubricated, so now it's corroded and excessively worn. Whenever you use wire rope, take the time to inspect it for all of these potential problems: kinks, unraveled places, and worn or stretched spots can literally cost you an arm and a leg. Well, now you've seen a little bit about how wire rope is made, how it's used, and how to inspect it for damage. Even though wire rope has some drawbacks, especially the way it whips when it breaks, it's almost irreplaceable in rigging work. When you've got a really heavy job, you're either going to use wire rope or chain. Chain has two advantages that make it better than wire rope for some jobs. First, it's more resistant to abrasion. Chain doesn't wear out as fast as wire rope does. Second, because a chain is made of individual links, it can turn around sharp corners without cutting or kinking. These can both be definite advantages. But chains also have some disadvantages for rigging jobs. One of these disadvantages is weight. Now this chain and this wire rope are both rated at a little over a ton. This rating is called capacity. That's how much this rope or this chain can lift safely with a built-in safety factor. Usually, rigging equipment is designed with a safety factor of 5. The tested breaking point is 5 times the rated capacity. If both of these slings have the same capacity, either one of them can do the same job. The difference comes in when you measure the weight of the chain itself. It's much heavier than the wire rope of the same capacity. If you're using chain on a hoist, it means that your hoist is doing a lot more work. It's got to be able to lift the load, plus the additional weight of the chain. Now this is an important point. Whenever you calculate the weight of a load, you have to take the weight of the rigging into account. Here's another disadvantage. Before a wire rope breaks, you'll see definite signs. But chains, though they don't often fail, won't stretch out or unravel slowly when they're overloaded. They'll snap. And the expression, getting buried in your work, may take on a new meaning for you. So you can avoid this fellow's uncomfortable predicament. Let's take a closer look at how a chain's put together. Each link is made of forged steel, welded together so it interlocks with the adjacent links. The first thing to look for when you're checking a chain are obvious cracks in the links and broken welds. Either one can cause the chain to fail. Here, where the links rub together, is the place where a chain wears out quickest. If the chain's seriously worn, this part of the metal will be thinner than the rest of the link. The last thing to check for is stretch. Measure 5 links distance with a ruler. Compare this measurement to the figure for a brand new chain. Some stretch is to be expected. But if the amount of stretch is too high, for example, 10% or more of the total length, the chain should be destroyed. It's no longer safe. Wherever a chain is used on a hoist, a come-along, a load leveler, or a sling, remember that a chain is only as strong as its weakest link. Now, we've been talking about how chains and wire ropes are made, how they're inspected, and we've also mentioned a few of the different ways these tools are used as rigging equipment. In a few minutes, we'll be back to discuss in detail one of the specific applications for rope and chain, slings. In the meantime, read through section 2 of your text and work the exercises. After that, feel free to ask your instructor any questions you have about how rope and chain are used where you work. We've been talking about rope and chain and the different ways they're used as rigging. Now we're going to spend some time on one of these uses in particular. We're going to talk about slings. We'll see how they're made, and we'll look at several of the ways slings are used for rigging different kinds of loads. Slings are short lengths of rope, chain, metal mesh, or nylon webbing that are used to attach a load to a hoist. Although there are many ways to rig slings, slings themselves really come in 2 types. First, there are slings that form a complete loop. These are called endless slings. And second, we have single leg slings with a connector at each end. No matter what a sling is made of or how it's used, it'll fall into one of these 2 groups, endless or single leg. Each of these 2 kinds of slings can be rigged in several different ways. Let's take a look at how slings are rigged. We'll start with endless slings. This rig is called a vertical hitch. It attaches the load hook to a single lift point on the load. In this case, the sling is attached to the eye bolt on the load with a shackle. Notice that while the load is in the air, its swing is controlled by a line held by one of the workers on the floor. This line, often made of fiber rope, is called a tag line. Here's a case where there's no eye bolt on the load at all. The sling's wrapped around the bottom of the load in a cradle hitch. 2 loops of the sling are attached to the load hook. The third and last kind of endless sling hitch is called a choker. It's easy to see why. When the hoist pulls on the sling line, here, the sling clinches up around the load here, like a necktie that's too tight. Using 2 chokers helps keep the load under control. The second type of sling is the single leg type. Now, here are a few different examples. Single leg wire rope slings are made with an eye at either end. In this example, the eye contains an insert called a thimble. The thimble maintains the shape of the eye and keeps the rope from kinking at this point. This chain sling is made with a ring at one end and a hook at the other end. But some chain slings have either 2 rings or 2 hooks, depending upon the purpose of the sling. Nylon slings are often made with loops at either end that act like the eyes on a wire rope sling. Sometimes, though, they're equipped with metal fittings that make certain types of hitches easier to rig. Now, as far as hitches are concerned, nylon slings are rigged just like wire rope and chain slings are. But with nylon slings, you have to remember that they're really not as durable as slings made of metal. First of all, the nylon webbing is easily cut, so you have to watch out for sharp edges or rough places that might start a slit in the material. Second, nylon slings will melt when they're exposed to heat. You have to be careful to keep them away from hot pipes or any other heat source that might damage the webbing. Now, any of these single-leg slings can be rigged in several different ways. Let's take a look and see what the different hitches are. Here's a single-leg vertical hitch. The sling attaches to the load hook and to a single eye bolt on the load. Remember, tag lines should always be used when you're lifting a load too high to steady by hand, but they're especially important when you're using only one pickup point. The same sling can be used to make a choker hitch. Usually, they're used in pairs. The best way to make a choker hitch from a single-leg sling is to use a sliding hook where the choker tightens. For an even better grip, chokers are sometimes given an extra wrap. This is called a double wrap choker. This hitch is called a basket. The sling passes around the bottom of the load, and both eyes are connected to the load hook at the top. Like chokers, basket hitches are often used in pairs. That way, a load is supported at 2 ends instead of at a single point. Here's the last type of hitch you can make with a single-leg sling. It's called a bridle hitch. In this example, we're using a 4-leg bridle. 4 single-leg slings come down from the load hook, and each attaches to an eye bolt on a corner of the load. But in some cases, a 3 or even a 2-leg bridle may be all you need. On the job, the type of hitch you use depends on the shape and balance of the load. The diameter of the sling will be determined by the weight of the load. But there's one more thing you have to know. How long a sling do you need? For the answer, we have to look at the angle made by the slings. In this example, a 1-ton load is being lifted by 2 vertical slings, so each sling must support half a ton. Here's the same load with 2 slings rigged at a 45-degree angle. Although the weight of the load is the same, the tension on each sling leg has increased to 3/4 of a ton. When the slings are rigged at an angle of 80 degrees from the vertical, the effect is really extreme. Now the tension on each leg has increased to 2 3/4 tons. Now, you're probably asking, if the weight of the load didn't change, why did the tension on the slings increase so much when we changed the angle? Well, the answer is pretty simple to visualize. Imagine carrying 2 buckets of water. Now, imagine carrying them like this. It would make quite a difference, wouldn't it? The shallower the angle, the less the tension you'd have on your arms. A sling works the same way. The more straight up and down it is, the less tension it'll have. The more a pair of slings are stretched out to the sides, the greater the tension will be. This brings us to one of the general rules of rigging. Slings should be rigged so they're within 60 degrees of vertical. Any more than that, and you stand a good chance of overloading your slings and snapping them. That means that when you're selecting slings for a rigging job, they have to be long enough to make that 60-degree angle. If they're too short, they'll be too close to horizontal, and the extra tension might break the slings. Little things like this can make a lot of difference when you've got 8 tons of metal overhead. Before we go on to some other kinds of rigging equipment, take some time to study Section 3 of your text. It'll have some hints that might help you solve some other weighty problems later on. Whenever heavy loads are lifted, several different kinds of rigging equipment are used. Usually hoists, slings, and loads have to be connected together to rig the job. Connectors are the attachments that tie the rigging together, so each piece of equipment can perform its function. There are a lot of different kinds of special attachments used in rigging work. Hooks come in all sizes and in several shapes. These are shackles. They're used to attach slings to eyes or hooks. They also come in many sizes. Eye bolts are screwed into the load so the slings have something to attach to. They come in 2 different types, a straight shank and a shoulder type. Hooks, shackles, and eye bolts are connectors. They link different pieces of equipment together. These attachments are all commonly used in rigging work. To be a good rigger, you've got to know how they work, what they are used for, and how to inspect them for wear and damage. We'll be discussing each type of connector shown here, the hooks, the shackles, and the eye bolts. The first type of connector we'll talk about is the hook. This hook has an eye, a shank, and an opening called the throat. This hook has a safety latch attached to the shank to keep a load from jumping off the hook. This kind of safety latch is one of the best types you can use. When the load's attached, there's no way it's going to slip off. Here's another good kind of safety latch. When it clips shut, the shackles are trapped securely. They can't slip off and cause the load to fall. Some kinds of hooks come with a spring-loaded safety latch, like this. This latch is better than nothing, but it's not as safe as the other kinds. Sooner or later, this spring will give out, and the latch won't be effective at securing a load. Open hooks, like this, afford you the least amount of safety. Since it doesn't have a latch, a load can jump off the hook if it's released suddenly or pulled at an angle. Now, if this is the kind of hook you have to use, there is something you can do to make it safer. The hook can be laced with wire or secured with a shackle to close off the throat. This is called mousing. Any open hook must be moused before it's used. There are several different ways to mouse hooks and increase their safety. Your text demonstrates these techniques. But remember, using a hook with an approved safety latch is the best way to be sure that a load won't jump off the hook. The place you'll most often see hooks used is on the end of a hoist. Hooks are used here because they attach easily and quickly. And they're strong. Hooks seldom fail by breaking outright. But hooks can fail. Usually they bend, spreading the throat apart. A hook like this is a hazard to everybody. This much spread means it's been severely overloaded. When a hook's weakened like this, it should be destroyed. not left lying around where someone might use it. Now, before you use any piece of rigging equipment, you have to inspect it for wear and damage. On a hook, the first thing you should check is the size of the throat opening. Measure the size of the throat with a ruler or gauge. The measurement you want is the narrowest distance across the throat. Then refer to a table that lists the nominal hook sizes for hoists of different capacities. A table like this is included in your text. If the hook you measured has a throat that's been spread open as much as 15% over the nominal figure, the hook's been overloaded, and it's not safe to use. Another way to measure the throat size of a hook is to use a gauge like this. Now, this gauge is made especially for a hook like this one. To measure the hook size, the widest part of the gauge is inserted in the hook opening. If the hook is in good shape, the edges of the gauge will barely drag along the sides of the opening. Any wider, and you've got evidence that the hook's been overloaded. Another thing to look for when you're inspecting the hook is cracking. Hooks sometimes crack right here, along the inside of the shank. Before using a hook, you should always make a visual check for cracks in this area. In the tool room, more elaborate methods are used. A dye penetrant test will show up cracks that are far too small to see with your eyes. You probably won't have to make this test yourself, but all hooks should have this kind of thorough inspection at least once a year. All rigging equipment should be double-checked for safety, once in the tool room and once right before the job starts. Shackles seem to be especially prone to abuse. Damage to the body or pin can make this connector worse than useless. Shackle pins come in two types. This kind screws into the shackle body with threads. Other shackle pins are secured with a cotter key after they're inserted into the body. Common uses of shackles include securing slings to hooks or eyes. When they're installed correctly, shackles won't open up or come loose. Most problems with shackles occur when they're misused. When threaded shackles are used this way, with the running end of a sling riding on the pin, any shifting of the load can cause the pin to unscrew. Keep the shackle pin on the eye of the sling. That way, the pin won't unscrew, no matter how the load shifts. Here's another bad practice. The pin on this shackle's been replaced with an ordinary bolt. Bolts don't have enough strength for this job. Use only the right size pin. Other items to check include eyes that are out of round, cracks on the shackle body, and stripped or stretched threads on the pin. Here's a shackle that shows definite signs of overloading. The entire body's been squeezed together. This is just one way shackles can be damaged when too heavy a load is lifted. Remember, any connectors, hooks, shackles, or eye bolts can be dangerous if misused. The best way to make sure they're safe is to inspect them closely and use them only as they've been designed to be used. That's especially true of eye bolts. There are two different types of eye bolts, and each has its special uses. This eye bolt has a straight shank. It's used only when the load can be lifted so that it pulls in a straight line with the shank. If the load's taken up at an angle, the eye bolt will bend or even break. Here's the second kind of eye bolt. It has a shoulder built into the shank, so it's stronger for angled lifts. But even shoulder-type eye bolts have to be rigged properly if the force of the lift is on an angle to the shank. Here's the right way to rig a shoulder-type eye bolt for an angled lift. The sling comes off the side of the eye, and the angle is always less than 45 degrees from the shank of the eye bolt. This is the wrong way to rig the sling. The force is concentrated at the top of the eye. When you lift the load this way, a shoulder-type eye bolt bends almost as easily as the straight kind. Now, so far, we've been taking a look at the do's and don'ts for three kinds of connectors: hooks, shackles, and eye bolts. Now, there are several other kinds of connectors that you might find on rigging jobs, but these three are the most common. They are found on almost every kind of rigging job. We've seen how they work, and we've talked about how to inspect each of these connectors for damage. Later on, we'll be talking more about how to select the right connectors and how to use them properly. Section 4 of your textbook has a lot of additional information about hooks, shackles, and eye bolts. Take a few minutes to go through the text and answer the questions. When we return, we'll be talking about some of the attachments that perform an entirely different function. We've been talking about rigging attachments, and so far we've looked at 3 different kinds of connectors: hooks, shackles, and eye bolts. We saw what they are and how they're used and how they're inspected for wear and damage. Now we're going to turn our attention to another class of rigging attachments: adjusters. We'll be talking about 2 different kinds of adjusters: turnbuckles and load levelers. Both of these devices are used to adjust the lifting point so it's directly above the load center of gravity. Let's take a close look at load levelers and see how they work. A load leveler has a cast metal body, an eye on the top, a chain that forms 2 legs, and a hook at the end of each leg. Inside, a load leveler has a sheave with pockets cut into it to hold the chain. An adjusting head protrudes through the body. To level a load, a wrench is used to rotate the adjusting head. As the sheave turns, the chain is fed through the body of the load leveler. One leg gets shorter and the other gets longer. The sheave is driven by a worm gear. So when a load is level, it stays level, unless you change its position by turning the adjusting head. Load levelers are especially useful when unbalanced loads are being lifted. The length of each leg can be adjusted so that the body of the load leveler is directly above the load center of gravity. So when you lift from this eye, the load is perfectly balanced. Just like any other piece of rigging equipment, load levelers have to be inspected thoroughly before every use. You can start with the hooks. Inspect each hook by looking for cracks on the shank. Then check the throat opening to make sure the hook hasn't spread apart due to overloading. A load leveler's chain should be inspected just like any other chain. Check the links for stretch, cracks, and broken welds. Look where the links rub together and check for excessive wear. The last thing to check is the operation of the sheave. Make sure it turns easily in both directions. Although some load levelers are pre-lubricated with sealed bearings, others have to be lubricated regularly. Check the manufacturer's recommendations and keep your load leveler lubricated properly. All adjusters can be used for leveling loads. Load levelers are the best tool we've got for making the big adjustments. But when we want to make very small adjustments in the length of a sling, we can use a turnbuckle. Turnbuckles have a threaded body and 2 threaded screws. The screws are threaded in opposite directions, so as the body's turned, the screws both move either outward or inward. Each screw ends in a connector, either an eye or a hook, or a shackle called the jaw end. Turnbuckles are adjusted by rotating the body. As the body is turned this way, the screws are pulled into the body, shortening the sling. Turning the body in the opposite direction lengthens the sling. The screws move outward, this way. The turnbuckle can make small adjustments with a high degree of accuracy. Before any turnbuckle is used, it has to be inspected closely for damage. First, check the body. If it's cracked or bent, the turnbuckle's too weak to be safe. Look at the screw connectors next. Make sure they're not bent or deformed in any way. Rotating the screws is an easy way to check for straightness. If the screws are bent, they'll rotate off-center or bind on the threads. Check the threads to make sure they're not stretched or stripped. And don't forget to check the threads on the body too. Whenever you use connectors, adjusters, or any other kind of rigging equipment, inspecting the equipment is one of the most important parts of the job. Attachments are especially vulnerable to damage. If they're overloaded or misused in other ways, they can be seriously weakened, and faulty rigging equipment can definitely cause a lot of harm. If you find damaged equipment, tell your supervisor. If it can't be fixed, damaged rigging equipment should be destroyed, so nobody uses it by mistake. Learning to use attachments properly is one of the biggest parts of rigging safety. Using the wrong piece of equipment for the job can be very unhealthy when you've got several tons of metal in the air. Your textbook contains more information on the selection and use of adjusters. Study up on Section 5, and in a few minutes, we'll be back to see how one person goes about lifting a ton or more with his own muscles. Have you ever lifted 2 tons by your own muscle power? If you have, you've used a hoist. Most likely, you used a hoist similar to this one, a chain hoist. Chain hoists give you extra lifting power by multiplying your muscular energy. As you pull on the hand chain, the load rises. But you'll notice that when you take up several feet of chain, the load rises only a few inches. The difference between this distance, the amount you take up on the hand chain, and this distance, the change in the height of the load, is your mechanical advantage. The greater your mechanical advantage, the more weight you can lift. We're going to be talking about 3 different kinds of hoists: differential, screw gear, and spur gear. We'll see how they're made, how they work, and how to use them safely. We'll start with the simplest kind, the differential hoist. Differential hoists aren't too common anymore because they're not terribly efficient. That means it takes more effort to lift a load with a differential hoist than it does with either of the other 2 kinds. But since differential hoists are relatively inexpensive, they're still used in places where only a limited amount of lifting has to be done. With that in mind, let's take a look and see exactly how the differential hoist does its job. As you can see, this hoist has an upper block and a lower block. The upper block has a hook that attaches to the overhead. On the lower block is the load hook. The 2 loops are parts of a single endless chain. Pulling down on the large hand loop raises the lower block, and as the load rises, the hand loop gets longer. On most differential hoists, a friction brake holds the load in the air when you release the hand chain. To lower the load, the hand chain's pulled in reverse. Let's take a close look at the upper block and see why a differential hoist works the way it does. Inside the casing on the upper block are 2 sheaves, a large one and a smaller one. The sheaves are connected so they rotate at the same rate. Both sheaves have pockets for the chain to fit into. The pockets keep the chain from slipping as it goes around the sheaves. The small sheave has fewer pockets than the larger one, so the chain moves around each sheave at a different rate. This rate is the differential that gives the hoist its name. The differential causes the larger sheave to take up chain a little faster than the small sheaves feed it out. So every time the sheaves rotate once, the load rises by 1 or 2 lengths distance. Differential hoists were once pretty common, but these days we have hoists that are much more efficient. One of them is the screw gear. This is a screw gear hoist. As you can see, it's quite a bit different than a differential type. First of all, there's no lower block. The load hook descends directly from the upper block. Second, the hand chain is separate from the lift chain. The hand chain is an endless loop, and it stays the same length no matter how high you raise the load. As the load hook rises, the extra slack in the load chain falls out in a loop. This loop is called the tail chain. If we follow the tail chain around, we can see that it's attached to the casing with an anchor bolt or pin. The anchor bolt secures the load chain so it won't feed completely out through the hoist. Screw gear hoists raise a load slower than a differential hoist does. That's because screw gear hoists have a greater mechanical advantage. Let's see why. Inside the block, we see two sheaves and a set of gears. The hand chain drives this sheave, called the hand wheel. The hand wheel rotates a worm gear. As the worm gear turns, it rotates a cog called the worm wheel. The worm wheel attaches directly to another sheave, called the load wheel. The load wheel raises the load chain, so in all, the mechanism changes a large motion here into a small motion here. That's your mechanical advantage. Screw gear hoists are especially good from a safety standpoint because when you let go of the hand chain, the load hook stays right there. It doesn't drop. When you want the load to come down, you pull the hand chain in reverse. Now, here's our third kind of hoist, the spur gear type. It looks a lot like a screw gear hoist. It has an endless hand chain, a single block, and a load chain that descends from the block. As the load is raised, the extra slack in the load chain falls out in a loop. For safety in lowering, this tail chain is attached to the casing with an anchor bolt or pin, just like the screw gear hoist. This particular type of hoist has a special friction brake that keeps the load in position when you let go of the hand chain. When you want to lower a load, you pull the hand chain in reverse. Some heavy-duty spur gear hoists have a different arrangement. They have a manually operated brake that has to be released before you can lower a load. For this hoist, though, a friction brake does the job without the need for manual controls. In general, spur gear hoists give you greater efficiency than any other type. They do this with a set of gears arranged in what's called the planetary gear set. This arrangement gets its name because there's a large central gear called the sun gear surrounded by smaller gears called planetary gears. The hand wheel attaches directly to the sun gear. The planetary gears rotate between the sun gear and an outer rack called the ring gear. So as the sun gear rotates, the entire group of planetary gears revolves at a much slower rate. The load wheel attaches to the axles of the planetary gears, raising the load chain at a very slow speed. This reduction in speed gives you the mechanical advantage you need to raise a heavy load. With this hoist, one man should be able to lift a ton. If the hoist is overloaded, a friction clutch causes it to slip and prevents the internal parts from being damaged. With either of these hoists, spur gear or screw gear, one man should be able to lift the entire rated load. If one man can't raise the load by himself, there's something wrong. There are two possibilities. One, the hoist is overloaded. Two, the hoist may be in poor mechanical condition. Either way, the hoist shouldn't be used for that load. The spur gear hoist is the most efficient and most expensive of any of these three different kinds. But the screw gear hoist and the differential hoist still have plenty of applications, depending upon the job at hand. In general, chain hoists are attached to the overhead and used for lifting loads straight up. Now, there are several ways that a hoist can be attached overhead. Pad eyes are often used in places where hoists are regularly needed. Pad eyes are welded to a beam, so they're fairly permanent installations. Beam clamps are portable devices. They can be installed on any normal I-beam. So wherever there's a beam, you've got a place to hang a hoist. Pad eyes and beam clamps are definitely the best way to secure a hoist to the overhead. But unfortunately, it's not always quite that easy. Sometimes you have to fabricate something special. You might have to weld on an additional pad eye, or even install a special beam to bear the weight of the load. There are several possibilities. But there's really only one main consideration. The overhead and your connection to the overhead have to be able to support the weight of the load. It's generally healthy to allow a substantial safety margin, unless you're planning to demolish the building anyway. Well, we've talked about three kinds of hoists so far: differential, screw gear, and spur gear. As far as operating any of these hoists is concerned, the action is pretty much the same. You pull the chain, and the load goes up. Now, we're going to talk about another tool that's very similar, the come-along, known to some as the ratchet lift. As you can see, the come-along has a ratchet handle instead of a pull chain. Otherwise, come-alongs perform just like a hoist. They can lift or pull a much heavier load than you or I could hope to lift alone. Here's how a come-along works. Crank the handle up and down, and the load chain rises. Now, to reverse direction, flick the ratchet pawl here into the other position. Then, you can control the descent of the load by working the ratchet handle. Come-alongs can really come in handy for a lot of jobs because they pack a lot of lifting power into a light, small package. This come-along will lift 1.5 tons. If you compare it to this 1-ton hoist, you'll see that the come-along is quite a bit smaller. And take my word for it, it's lighter too. But come-alongs also have their limitations. First of all, they're only useful for short lifts. They don't have that much load chain. Second, come-alongs aren't available in really high capacity models. For anything over a couple of tons, you're probably going to have to use some other kind of hoist. Whatever kind of hoist you use, remember the basic safety precautions. Make sure the hoist has the capacity you need and inspect it carefully before each use. Check both hooks for cracking or spreading. A gauge like this can be used to measure the size of the throat opening on the load hook. The narrow part of the gauge is used to check the amount of stretch in the chain. Then, the chain should be given a visual inspection for wear, broken welds, and cracks that indicate overloading. Finally, check the anchor pin to make sure the load chain is securely attached to the casing. As far as the operation of the hoist goes, check the actions for smoothness and free movement. Every hoist needs to be lubricated regularly. If the pull chain's hard to move, check the manufacturer's instructions and oil or grease the hoist according to specifications. And be careful where you lubricate the hoist. A little oil in the wrong place can make your friction clutch a lot less efficient. Proper care of equipment is one of the biggest parts of safe rigging. Hoists, chains, hooks, shackles, and adjusters are the tools of the trade. As you gain experience in rigging, you'll learn more about them. The simple facts you already know: every piece of rigging equipment has to be inspected before each use. Any single equipment failure, a stripped out shackle, or a single defective link of chain can be deadly. You also know how important it is to plan the job thoroughly. Find the weight of the load, check its balance, and measure clearances so you're sure you've got room to move the load. Rigging safety is a combination of all these factors: planning, equipment, and good practices. Any rigging job has built-in dangers, so don't complicate matters by making yourself a target for would-be bombardiers. Sometimes little things count too, like removing your fingers from the load before they're removed for you. There's plenty more to learn about rigging, and a lot of it's simply practice. You'll be starting your own exercises soon, if you haven't already. While you're practicing, remember to use your head so you won't lose it.